Okay, so I don't know how many people have joined as yet, but why don't you all come ahead and have a look at it? So I can solve some of your problems. Now, quite a few lectures are over. So some things that you haven't understood, you can, go ahead and speak about it easily, and I'll try to solve the problem, and whoever hasn't thought of the question can understand what from the other. So today I just want to speak a little bit about, the lectures where the laser chain was considered, where you had a oscillator, the MOPA chain, master oscillator and whole set of chain of amplifiers, I had spoken about. In that, I devoted most of the time to the concept and the physics of it. But in actual fact, there is a lot of electronics involved in it, you know, very fast electronics, which I have not touched upon. Um, but then if somebody from the electronic stream has gone through these lectures, it would be a big help to them. And I want to just inform that there is a lot of electronics involved in it. And the electronics involved here are colloquially called fast electronics, because those laser chain and the short pulses are in the nanosecond and the femtosecond range. Femtosecond, of course, the electronics cannot detect, but okay, up till the picosecond, high picosecond, electronic detectors will work. In any case, you have to deal with very fast electronics, any of your electronic materials, it may be whatever the capacitor charging, discharging, those have to be fast in the picosecond or the nanosecond scale. And to manage that is a study by itself. You've got to see, when I say the laser amplifiers. So suppose you have one oscillator and then you have 10 amplifiers. Now all of them should work in tandem. Okay, so the moment the oscillator pulse comes out, then the first amplifier should be ready. Should be ready in the sense the population inversion should have already taken place. And for that population inversion to take place, you should have already sent in a discharge into that. Or you should have flashed your flashlight, if at all, or started some laser, which is the pump system of that. So all these things, the timings are very important, So you have to time it such that when the oscillator pulse comes out, the first pulse is ready. And it is pointless the second amplifier being ready. Only the first amplifier is ready. The second amplifier also has to be ready by the time the pulse has crossed the first amplifier. So there is a lot of timing involved. Timing and synchronization makes a very, very big difference. Okay. In the pulse that you have to output, or the pulse that you are amplifying, or any, basically controlling the pulse. So that is a big part of lasers as it is. Okay. And I think uh, I think, and in this regard, in a laser amplifier chain that I spoke about, there are many places where such chains are being developed. Not only, I'm not talking of just India, but in the rest of the world also. So, getting a chance to work there or is really great, and it is completely new kind of science. And there are quite a few places where these chains are there. USA, definitely, I've given you some example. USA, France, and all that, and India itself. in many of the institutes like TIFR and BRC and CAT in Indore. All these places have it. Mm. And some of them are taken up in a very commercial scale. So it could be like a job for you, to work in this field. And other than that, if somebody takes up making lasers, making lasers by itself, starting an industry of that kind, that sort of industry is not there in India. Nobody is making lasers. Most of the time in the laboratory, what we do is we buy these lasers. So it would be a great thing if you youngsters could start a startup and make lasers and send them to the rest of the world if you like. So that would be a very good thing. And there is no dearth of the kind of lasers. It could be a helium neon laser, semiconductor laser, so many, and they are used rampantly in many things. Oh, is there a question? Hussein Safi, good afternoon. Oh, yes. Hussein, good afternoon to you also. Nice that you have joined. So what kind of questions do you have? I mean, what difficulties have you found, or which part did you not understand? We can discuss that. Any question by itself. So I'm waiting for your question. Then I can take off in, it gives me an idea of which part the students haven't understood or felt good about that part. That part is important for me. Last time also, when unfortunately the electricity went off, we were in the middle of some chat. You were there, and you said that this course is a mandatory course for you to go ahead with your project. I think you told me project. So what? How far have you studied all the lectures and understood it or not understood it? Whichever way is always welcome. Are you a student of any particular college, university where you have to take up this course? Which university are you from, or which college? In Bombay or out of Bombay? So another thing I wanted to tell you was the big use of lasers in spectroscopy. So as I've covered in my lectures there, I've covered in my lectures there on spectroscopy, laser Raman, and such. Most of the time, these are the things that are being used where laser is being used. So I think more than around 50 lectures have been covered. You people have been given the lecture sessions. 50 lecture sessions must be with you. So you can quickly go through that and just write down what you what you don't understand, what you understand, and what you liked, what you did not like. That would be nice. Uh, Omkar, इसको कुछ ट्रिगर करना है क्या? क्योंकि एक जना है, वो कुछ पूछ नहीं रहा है, इसलिए मैं सोचा ट्रिगर करना है क्या? कुछ कुछ ट्रिगर अपने आप आएगा ना इधर क्वेश्चंस। लास्ट सेशन में एक्चुअली 25 पीपल ऐसा आया था ना, तभी वो इलेक्ट्रिसिटी चला गया था। और तभी और एक वन लेडी थी, उसने भी कुछ कुछ पूछा। अभी ये जो ज्वाइन किया हुआ है वो तो आई थिंक I would like you to go back to the first lecture, which gives you an idea of all the Nobel Prizes. Uh, in those Nobel Prizes, I think I had mentioned holography, and you still haven't been given those lectures. I think it'll come in next week. Yeah, in those, the holography part I have described in a lot of details. So just check out there uh, what could be the thing. Have you been doing the assignments also? Yes, the final exam pattern, they are all multiple choice. They're all multiple choice. Don't worry so much about the exam, because they're all easy questions, and most of them are, if you've done your assignments well, I don't think you'll face any trouble. So don't worry about that. Ghosh, where are you from? Ghosh, from Bombay or outside? Are you a regular third year student, or MSc student, or BSc student, or BTech student? I'd really like to know, because if you are a graduate level student, then I would like to know how you found the lectures from Kolkata. But are you a graduate student, or a MSc or uh, BSc or BTech, MSc in physics? Okay. So was this MSc in physics? Did you have any course related with lasers, or with spectroscopy you may have had? Yes, in spectroscopy, you would have had a subject in of spectroscopy, because spectroscopy by itself is a very old subject. Lasers may have been introduced newly in many cases, but spectroscopy definitely would have been there. Okay, okay, okay. Okay, in atomic and molecular physics, you have, uh, that's where the spectroscopy part comes in. So you definitely must have had laboratory work. Did you have lasers in your laboratory? Okay. And you have to tell me whether the lectures were comprehensible enough for you or not. Was it too low a level for you? Too elementary for you to understand? Bachelor's, both atomic and molecular physics, you did as a bachelor's degree, you had done that. Okay, so graduation level was, you have done atomic and molecular physics, yes. Yes, that is definitely introduced at that stage. Hmm. So what is your major in MSc physics? Major subject now? So what I'm asking is, what is your major subject in MSc physics? Or there is nothing like a major subject? Okay, here there is Spurti who had come last time also, and she was asking a few questions. So any tips for the exam? Uh, the only tip is that you do your assignments well. Means you take your assignments, even if you've made wrong answers, now at some time the answers are given and you know the right answer. So once you know that, and it is a multiple choice question. So there is a lot of things, if you haven't understood in the lectures itself, if by doing the assignment, you know the way the assignment questions are put, it is like that, so that you have a better understanding of the lectures. So you go through your assignments well, and you will be able to definitely do well in the final exam. Oh, okay. Okay, so Mr. Ghosh, he says his specialization is in astrophysics and cosmology. But I was coming from as an interest in material science and condensed matter. Oh, yes. Yes, if you have so much interest in material science and condensed matter, you are the one who has to make semiconductor lasers. So you would have understood semiconductor lasers very, very easily. You know, we do need material scientists to make semiconductor lasers. Okay? And it is very useful in many places. For me, it was a little confusing when we were discussing the multiple problem of MOPA chains. Yeah, keep up with all the points was a little challenging. Yeah, when I just started this session, I was speaking about the MOPA chains, but the electronics involved in it. You know, which part was exactly confusing to you? See, you were confusing between the amplifiers and the oscillators. Was that the confusion, or you wanted to know uh, how are they different? You know, I can understand one can get a bit confused about that because they are both sort of lasing material. But in case of in case of MOPA chains, you have only one oscillator which gives you the pulse that you desire, the pulse shape or whatever from that oscillator. Oscillator is always the beginning of any chain. So that gives you the pulse that you desire. It will have some particular width of in time. It will have some particular energy. Now, what the amplifiers are doing is all the characteristics of that pulse, which is coming out of the oscillator, will be preserved in the amplifier. We'll try to preserve that. But your energy will go on increasing. Okay? The energy part goes on increasing. That's about the only thing. I mean, you can have a large oscillator, take out a lot of energy from it, but there are limitations in that. So to overcome those kind of limitations, you need these amplifiers. So they come in a big chain, one after the other. Yeah. Any point specifically in the MOPA chain? That concept is a bit new. It's not yeah. In fact, you won't even find it in many textbooks because it is a relatively new concept. So can you tell me exactly which point was challenging or why we need a MOPA chain at all? The basic idea of a MOPA chain is you need a large energy at the end of the story. You just need a large energy. Oh, oh, okay. Yeah, yeah. Yeah, I think I agree with you. There are challenges, but then yes, we have to overcome those challenges. And that's why I suppose it's not there exactly it's not there exactly in a book sense. Few books have come out of it, but it is kind of an ongoing process of, yeah, you develop problem and we develop a solution. And again, in that solution, there is a challenge. Yeah, yeah. I think you've put it very nicely. Yes. So life is just to solve problems, you know. Life is just to solve these kind of challenges only. Yeah. So the whole thing is that each of those amplifiers, they have a certain limitation, I would say. You know, so you have to work within that limitation. Like the first limitation in that chain was, you know, you are going on increasing the energy. All you have to do is increase the size of the amplifier. but then physically also there is a limit. So everything is within that limit what you can do. Then you have to think of some other solution, how to increase the energy or the intensity. Then you shorten the pulse. So there are these 2 3 parameters, the shortening of the pulse and increasing the energy. These 2 parameters you have to play with. Uh, Once you play with that, then you can go ahead to some extent. Yes. So since you want to do a lot of research in Europe, last time you told me that, uh, there'll be no end to such challenges, even in Europe. Forget India, even in Europe, if you're doing that, there will be a lot of challenges. So take it, embrace it happily, all the challenges. Hussein Saifi, why don't you have a few questions yourself? Oh, I welcome from all of you. 3 of you have asked questions. One, A. Ghosh, he has asked. But yeah, he... Hussein Saifi, I think you wanted to do something in, if I remember last time, you wanted to do something in photonics, isn't it? Those are actually, a smaller level of doing all this. These are smaller levels of doing these things. Photonics, you need, small, they are low energy pulses, but then, it's used a lot in data science, how to transfer data and things like that. So Spurti, you can tell me. I think you have understood the lectures well, because you asked a good question, that one challenge and then a challenge after that. So you can tell me whether all the lectures were easily comprehensible or not, or was it too low a standard? I don't know. You have to just say that. Then next time maybe I can put in a higher standard to it, or a more difficult lectures in my set of lectures. See, because there is no end. There is no end to all these studies. I have put it in 60 lectures, but it will go on and on and on. Each of them has a further intricacies which have to be taken care of. I've tried to put it in just a compact form. Ma'am, what part of our course curriculum would be overlapping with the optical system design? Device making. Okay, so if you are interested in, something like telescope devices and such devices, in fact, in this course, there was I called it lasers. It was called lasers, but it had a base level of certain optics involved in it. So that, in that sense, you take away from the lectures which are the optics part of it. It need not be exactly lasers. There is so much optics involved in it. Like I have spoken about the gratings, then interference patterns, and Ghosh has asked about he is doing astrophysics and astronomy, he said that. And even in that, the interference patterns of stars and all that, which I have included in my talk, very little though, from faraway stars, how they are detected on land, on Earth. They're all by this interference patterns. And that all forms a basis of optics, which is general optics. Okay? So I'm sure you can make use of that in making these devices. And since you are so interested in making optical devices, there is uh, no end to it. In fact, in those MOPA chains itself, there are so many small devices that have been used. Like Pockle cells have been used, and then and Pockle cells involve a lot of fast electronics, which I was talking about. So you are making a small device which is called a Pockle cell, which allows light to go in and allows a polarized light to come out. It plays on the polarization. So these kind of devices, I've given you those explanations in this very little in compact form. You can go deep into that subject on your own. But oh, yeah, you have to find the time for your revision. See, because it is not a classroom lecture where if it were a classroom lecture, then I could have known your difficulties immediately and given some solution, and it would have been a revision. But now you have to find, because you have those set of lectures with you, anytime you can go back and refer to them. I thought that was the main idea of remote learning like this. Okay. Yes, yeah, that is true. But you have to find your own time for that. Yeah. Hey, Ghosh, a very engaging session currently in lab. We'll watch the session in recording. Okay. Okay, that's all right. Go ahead. It was nice talking to you and nice knowing some opinions. If you don't get a feedback, it's very difficult to, you feel uneasy yourself. Okay. That's nice. I think only three of you are good to have a conversation with. Yeah, right. Right. Yes. Yes. Spectroscopy is, spectroscopists are the biggest users of lasers. You can't go to any lab now of a spectroscopy lab without a laser there. Okay. And those lasers which the spectroscopists use may not be MOPA chains. They might have, like you said, the MOPA chain. When you go to long and long chain, it becomes a bit more challenging and complicated. But in a spectroscopy lab, they will have just an oscillator in a general lab to do their spectroscopic studies. Or at the most, there will be just one amplifier. Then all the complicated parts don't come into the picture. And they are available also commercially, because most of the problems at that level are solved. Like in a MOPA chain, most of the problems are not solved fully. So that's how there is a loose end which is there. But in case of a spectroscopy lab, if you just have one oscillator and at the most one more amplifier, that is a good thing. So in a spectroscopy lab, yes, a spectroscopy lab, having a single wavelength is the most important thing. Okay, having that either single longitudinal mode or single wavelength, one wavelength. Though you can never have ideally one wavelength, but the best you can, that is what the spectroscopies desire. But in case of a MOPA chain, you want all the wavelengths in your pulse so that you get a short pulse. So the aims are a bit different. Here you want one wavelength and there you want a short pulse to get a better intensity. Oh, okay. So, but those instruments are completely different. You need a lot of optics in that, definitely, but in case of astrophysics, those are in that. See, there is one laboratory close to Pune. They have it is a collaboration with a foreign laboratory. I don't remember exactly which country, but they are trying to put in a Michelson's interferometer. Michelson's interferometer in a very large scale. So, I have told you what a Michelson's interferometer does. So you need this coherence part. That's why the laser is important. The spatial, the coherence time is important in case of a Michelson's interferometer. So the whole idea is to use this Michelson's interferometer to get the interference patterns from the stars. So those instruments, they have a different kind of problem other than just this optical part. They have a problem of stability. Stability means you have these Michelson's interferometer with these huge long arms. And suppose it is not stable, you are getting a light from, say, from the stars, which is coming from so far. You have to collect that. And you detect everything through the interference pattern. So first of all, you should get an interference pattern itself. Getting that interference pattern is the first problem. And for that, you need a very stable instrument. So in fact, they have to even decide on which place to set this up so that even the seismic interference doesn't come into the picture. So you can't locate it in a place where there are tremors on the floor, close to an earthquake. May not be an earthquake, but just tremors. So those kind of instruments have a different outlook to it. But definitely there is optics involved in it. That's the base part. But yeah, I think you have very nice interests. And I hope you're successful in achieving all those interests. Yeah. I think today most of you had opened up a lot to speak, though I feel you were the most interactive out of all. Spurti, yes. Hussein hasn't spoken anymore in this. ओमकार, विजय, बंद कर दे क्या? क्योंकि और तो कोई आ नहीं रहा है। जो 3 आए थे वो दिखाता है ना कितना आए हैं, कौन कौन सुन रहा है। इधर तो 3 जनों ने क्वेश्चंस पूछा, और टोटल कौन देख रहा है या
टोटल सिर्फ काउंट होगा चल रहा
हाँ काउंट कितना? हम्म
है।
हम्म तो मैं कंप्लीट कर देती हूँ। I think if there are Spurti, I live in Pune. Oh, very nice. Very nice. And do you uh, do you study at the NCRA? I guess you are talking about. Yes, GMWRT, ma'am. Array of telescopes. Yes, yes, I have been to that place. Yes. Oh yeah. So if you want to work there, that will be great. Yes, you should have some idea of the telescopes that are there. Huh? So that's very nice to know. I hope you're successful in your wishes, and all those wishes should come true for you. Okay, then. Good luck to you. Do well in this exam. Yeah. So I think very few people. Yeah. Okay. Great. 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 So I think we are not getting any more people coming on board. So I think I should close this session here. And there will be one more session. Uh, yeah, no, it's fine. It's fine, Spurti. It's fine. Fine. It's fine. Absolutely fine. I enjoyed talking. So there will be one more session before your exams, perhaps. That will be scheduled and you will know about it. Okay. All right then.